Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 79, word search. Given an m into n grid of characters board and a string word, return true if word exists in the grid. The word can be constructed from from letters of sequential adjacent cells, where adjacent cells are horizontally or vertical neighboring, which means what? We can move top, left, right, or bottom. Fine. Now, the same letter cell may not be used more than once. So we cannot use the cell once more. If we visited that, that's it. Okay, fine. So this is an interesting question. See here. This is a small application I have created. See here. What is the number of row? It is 3. Take this first example. It is 3. And what is the number of column? It is 4, right? Okay. Now I enter the value also. A, B, C, E, like that. I enter the value also. What is the search value? It is A, B, C, C, E, D, right? If I press on the search word, what is giving? The word A, B, C, C, E, D is found in the grid. Okay, and okay, it also giving the path. But in question they haven't asked the path. They are asking what? Only true or false, whether it can be found or not. So it is interesting, right? In visualization, right? Now we are going to see the visualizations code and logic behind this. Okay, it is so simple, but in visualization it is so difficult to understand, right? But when I'm teaching it, it is so simple. Concepts are simple. Okay, it is so simple. Let me teach the concept. See here. Let us take this example itself. Now, just tell me. First of all, they will give a board, and also they will give a string, right? They will give a string. Okay. Now we want to tell them that whether the string can be constructed from this board if we can only traverse to top, down, left, and right. That's it. So if I take this A, I can say first I will traverse to this B, then to this C, then to this C, then to this E, then to this D. So this is the path for our answer. Can you understand this? Yes. Fine. So this is what they are asking us. Fine. Okay. You may ask whether we want to only start with this A. We cannot start this with A. We can start, but we cannot form this string. That's why we haven't start from that. Okay. Now, what is the logic behind it? What is the logic behind it? Okay. See this carefully. Initially, I want to go and traverse each and every matrix elements. Every matrix elements and check whether that element is equal to the first element of the search string. Okay, see here also A, here also A. Let me take any other color. Here also A. Okay, both are A. Okay, from here we can start any of them, right? Okay, try those two possibility. Okay, initially I am trying this A. Okay, now from this A I can go to right or down or left or top. Okay, if I go top, what is the value? It is S. Whether S is equal to B? No. B is the next character to A, right? No. Whether D is equal to B? No. Whether down there is any element? No. Here also no element. So I can say from this A I cannot construct. Okay. Now check for this A, because this A is equal to the 0th index of the string, right? Okay. Now from this A I can go to this B or to this S. No. Many of them are collapsed with the question itself. The question is saying that we cannot visit the cell once more. You may ask, we already visited this yes, then how can we just visiting again? Just wait. If I visited this A, if I take this A as our answer, then I gone to B, then again if I go to this A, it is wrong. But if I took this B in any other word, in any other string, I haven't took for the current string, right? So it is valid only. Can you understand this? So I can also take this S, because it is individual string. It is another. It is for this A, not for this A, right? Okay. Now second character is what? B. Okay. Here is B, but here is S. So we don't want to go here. Can you understand this? We want to go to this B. Okay. Now again I am going to next characters, whether F or C should be taken. Okay. See the next is character. It is C. So we want to take this. We don't want to go to F. Okay. Now from the C, I can go to either this E or this C. Just observe. I can also go to top. I can also go to left, but left is already visited. Top is there is no more element. So I can only go for what? Right or bottom. Can you understand this? Okay, fine. Now it is E, so we cannot take because what is the next character? Next character is also C. So we can go here. Okay. From this C, I can go to this S or this E. I cannot go to this F because F is already visited, C also already visited. Okay. Now what is the next character? It is E. I can go to this cell, this S. So we cannot go here. Fine. Now, what is the next character? It is D. So the next character is E, but going to the left side, it is D. So I will go to this left side, ignoring this E. Can you understand this? So, what is the core logic we have found? Okay, if I have a cell like this, we can go a 4 possible ways. What are those 4 possible ways? I can go to left. If I go to left, what should I do? I should reduce my column by 1. Okay. I can go to right. If I go to right, what should I do? I should increase my column by 1. If I go to up, what should I do? I should decrease my row by 1, right? So row minus 1. If I go to down, what should I do? Row plus 1. Can you understand this? So these are the 4 combinations for each and every cell. Okay. First of all, we are going to check whether we can start from this cell, this cell, this cell. And for that each and every cell, again we are going to call for these recursion calls. Okay, and we are checking whether it can be found or not, like that. Fine. Now, what is my base case? What is gonna be my base case? Okay, talking about a base case, what's the first thing we want to notice? Okay, first thing is, first of all, we want to write the function for this recursion call such that it is more easy to write the base case, right? Okay, what's the function? First of all, I can say I need ij, which are denoting the current index row and column, the position of the current index. Okay, and I want the index to denote this word index. Can you understand this? We are traversing to this index, to this matrix index, word index, and also we are traversing this word index also, right? So we want this index also. Can you understand this? Okay, now keeping this as in our mind, let us write the base case. Okay, now what's the base case? First step is this I denoting what? The row, and this j denoting what? Column. So I can say 0 is less than or equal to I, which is less than the row length. Can you understand this? And also 0 is less than or equal to I, which is less than the column length. Okay, if it is not the case, then what should I do? I should return false. Okay, so this is my first base case. Now, what is my next base case? Okay, fine. If my index goes to the length of that word, my index goes to the length of the word, then what it means? It means we should return true. Why? You may ask why we are returning true? Because this all characters are completed and it means what? The end, which means what? The all characters are found in that cell or in that board. Okay, so this is the second. What's the third? Whether we can revisit a cell? No, right? We cannot revisit a cell. Okay, just put it. If the current cell, this inj, is invisited or is visited already, then what should we do? We should return false because we cannot go in that path. Can you understand this? Okay, to do this visited, how can we do this? Just see here. Visitor can be constructed in 2 ways. One is you can use set. It is easy. If it is in set, we want to do what? We don't want to do anything. We just return what? False. Another thing is we can construct a matrix of size m into n, like the original given question. In question itself, they have given a matrix like. For that, we want to create a matrix and initially set those values as what? 0, which means what? Not visited. And whenever we visit, we want to make that value as 1. Whenever we are backtracking, we want to again make that as what? 0 to get the original matrix. Okay, so this is the visited. So these are all the base case I need. Other than that, we need any other base case? Yes, we want a base case for the checking condition. Okay, what is that condition? Let me tell you that if the current index, which means the word of index, is not equal to the current cell index, so it means what? Board or inj, then what should I do? I should return false because going further cannot give my answer, right? So these four are my conditions I should include in my recursion. Okay, what should be my recursion call? If I give the recursion call, it will be so simple. Just return what? Just return either left or right or top or up, okay, or down. If any one of it is true, then my answer should be what? Returning true. I understand this. If I find the element in left, up, down, right, then obviously we'll return true, right? So we will return true. So this is all about my code. Okay, now it is time to see the code, and I will tell you little code optimization. It is not like time complexity or space complexity optimization. It is like code optimization. Writing a code in a neater way. I will tell you. First, see this. Def search. Inside that I, J, and in this comma scene. You can give this scene, or you cannot. You don't want to give this scene inside this parameter. It actually take in Python. But if you are using C plus Java, you should give. Okay. Now, if in this is equal to len of word, which means if in this reaches to the end of the word, what should I do? I should return true. This is my first condition. Okay. Now, if I is equal to -1 or j is equal to -1, which means what? We exceeded the array. We exceeded the matrix boundary. Okay. Or I is equal to len of board, or j is equal to len of board of 0, which means what? We exceeded the range of boundary again. We can also put like I given the range like, right? We can also do like that, but still we can also do like this. Anything is possible. Okay. Now I and j is in scene. Scene is what? The set. Scene is what? That set. If it is in set, or word of index is not equal to word of I and j, I should do what? I should return false. So I combine all those three conditions and kept as a one, because all are returning false, right? Okay. Now scene dot add of I comma j. Before we are traversing to the next cell, we should consider that I finished this cell, I visited this cell. That's why. Now up is equal to, I just going to the search for the up. What's the up? It will be I minus 1 j and index plus 1. Index plus 1 is common in everything, because we are just going to the next index of the search word, right? Okay. Similarly, right, down, then left. Okay. At last, scene dot remove of I and j. I should remove that value, or I should remove that index from my scene after completing each and every recursion and while backtracking. Okay. And then I should return what? If left is true, or right is true, or up is true, or down is true, I should return what? True. That's why this return statement is like this. Okay. Now, for I in range of len of board and j is range of len of board of 0. I'm just traversing the matrix, and if search of I, j, 0 set of is true, then I will return true. Okay. We can also write here a small condition like, if the first index of the search element and that cell element cell value is equal, then we can also do like this. But when I am calling this, whenever it goes to here, this condition, it will automatically breaks. Can you understand this? Okay. If I just traversed all matrix elements or all cells and still I cannot find it, I should return what? False. Let me submit it. Yes, it is submitted successfully. Now I will show you how to make this code somewhat cleaner. Okay. Just see here. We can make this still a little cleaner. I just use a direction array or list, anything. Inside that, I will give some coordinates. You may ask, what are these coordinates? Okay, I will tell you. Just take for example, I want to move left side. Okay, and my index is what? Something like 2, 1. If I move left side, what should I do? I should decrease my column by 1, right? So it will become what? 2, 0 only. Row is not changed, but column only changed. Okay, so what we are doing like that, we are only minusing in the column. So I can say we didn't do anything in row, but we are minusing in column. Similarly, for right, we don't do anything in row, but we are adding 1 in column. Okay. Now for top, what we are doing, we didn't touch anything in column, but we are subtracting 1 in row. And similarly for bottom, we haven't done anything in column, but we are adding 1. So these are the directions I want to focus, right? If I add this to anything, this all 4 values, then I can get the left, the right, top, bottom. So just practice this. Hereafter, you want to do this whenever there is a backtracking or dynamic programming or anything like that in matrix. Okay, in graph also, you want to do like this. Okay, now see here, same code. Here only there is a difference. The result is equal to 0, and for x comma y in direction, in this direction I am taking x comma y. Now result r is equal to, so I am doing r with the result y, because if any one is true, then I should store what in result true. So see here, search of I plus x, j plus y, and index plus 1 and c. Can you understand this? We can look, this looks like simple, right? This looks like a clean code. So that's why we want to use this. Other than that, it is same. It is similar. Let me submit it. Yes, it is submitted actually. Now, what is the time and space complexity for this? Okay, I can say my time complexity and space complexity gonna be like, my time is O of m into n for traversing each and every cells in the matrix, and also into 4 power L. So this L denotes the size of the word, and also into a log of what is the utmost size I can have in my scene. I can have utmost L. Okay, I will detail explain this. So this is what matrix traversal. Okay, and this is what all possible values. I want to do for left, right, top, bottom, right, and this log L is what for including in our set. We are using the set data, right? And what is space complexity? It is O of, we just go up to what? To L only. Recursion will be up to what? Up to L. Can you understand this? So this is our time and space complexity. Okay. Further, if I use a matrix to the visitor set instead of this visitor set, then I will get what? 4 power L. That's it. And space is what? It is similar. Okay, and space will be added like into m into n, because we are using what? Matrix, right? Sorry for inconvenience. We are using what? A space. That is what? Okay. So this is our 2 time and space complexity. Try by you one for the matrix. Okay, just put a matrix of size equal to the board and make this as 1. Initialize with 0 and make this as 1 if we are visiting, and again while backtracking make again as 0. Try by yourself. Okay, and this question is similar to what? Maximum gold path. I think this is the question. I think maximum gold path. I also put this video in the YouTube. You can also see this in my description. Okay, this is also a similar problem to this. Thank you.